Okay, so today we're going to look at 10.2, Simplifying Radical Expressions, Part 2. Today we're going to look at what happens when there are variables under the radical. Okay, so this lesson can be kind of tricky. There are a lot of different rules, so if you need to pause it, rewind, go back, come to bonus to see me, just keep in mind that this is even hard for students that are in pre-calculus and algebra 2, so don't worry if it doesn't make sense right away. That's why you can come see me if you have questions, okay? So let's consider if we have x to some power. All right, now, if the exponent, okay, so here's our exponent under the radical. If it is an even power, okay, we're going to divide that exponent by 2. All right, so now, so that means like, let's say, square root of x to the 4th or square root of x to the 12th. So if that's an even number, so x to the 20th, okay, and so on. So there's 2 different cases, right? We're going to divide the exponent by 2. So case 1, if we get an even power, for example, okay, if we have square root of x to the 8th power, our answer is just going to be x to the 4th. You basically take the 8 and divide by 2. All right. If we have an even result, then that's it. We leave our answer like that. Okay. And I'll break it down when we do the examples. We'll come back to this. If case 2 is what happens if we take the square root and we get an odd exponent. What we have to do is we have to put it in absolute value. So here's an example. I have square root of x to the 6th. So first I'm going to take x to the 6th, I'm going to divide by 2, and I get 3. So do you see how you get an odd exponent? Whenever we get an odd exponent, we're going to put it in absolute value. Okay, and that has to do with the fact that something could be, like if you have a negative 3, right? Negative 3 squared is positive 9, but also positive 3 squared is a positive 9. Okay, it gets a little tricky with the theory there, but that's what I want you to know. Okay, so if it's an even power, we just divide by 2, but if you get an odd result, we're going to put that result in absolute value. Okay, now if a is an odd power, we're still going to divide by 2, but we're always going to have a remainder. So the quotient is now the exponent on the outside of the radical. The remainder is the exponent on the inside. So let's take x to the 9th, right? So if I take 2 and divide it into 9, I get 4, right? And then we multiply, and I get 1 is the remainder. Okay, so what I end up with, the 4 goes on the outside. That's the outside exponent. So I get x to the 4th power, and then because I had a remainder, I'm going to put an x to the 1st back under the square root. Okay. All right, so those are the 3 rules. I know that they're a little tricky, but hopefully once we see a few examples, you'll get the hang of it, okay? And I want you to have this handy, especially when you're doing the homework, to refer back to. Okay, so let's try some of these. The square root of x squared. Okay, so we're going to divide that by 2. If I can spell divide, there we go. Okay, so we're going to divide that by 2. Well, 2 divided by 2 is the 1st power. And since we started with even underneath, we're looking at case 2. So did we end up with an odd result? Yes, I'm going to put that in absolute value. And really, you don't need that x to the first. You could just write x. Okay, b. I have an even power again. So here, I also have a 4 in the front. So I'm going to have square root of 4 is 2. And then x to the 4th divided by 2 is 2. Do I need to put absolute value? No, because whenever you have an even result, you don't need to put an absolute value around it. Next one, square root of a to the 3rd. So 2 goes into 3 one time, and I have a remainder of 1. So I have a times the square root of a. Now, I realize that this might be, for some of you, it might be a little confusing. So think sometimes, like if I have an a to the 3rd, that's an a times an a times an a. Remember how when we first talked about square roots, you're looking for pairs. So notice I have a pair of a's. So that is the one that goes on the outside. And then you have one left over that goes on the inside. So if it's easier for you to keep, think like that, you can definitely continue in that method. All right, next one. So I notice that the 2 and the 6 are even. So those will end up being on the outside of the square root. So I get 2 goes into 2 one time. Let me put the c next to it just so I get c, 2 goes into 6 3 times. Now, both of those had an odd result. So that means I'm going to put an absolute value around these. Now I'm going to look at the b to the 5th. Okay, so 2 goes into 5 2 times. So I'm going to have b to the 2nd power. And I have 1 as my remainder. So that means I have a square root of b to the 1st at the end. And here's my answer. You don't need to put those first powers, but you can leave them. It won't make any difference. Next one, 16b to the 4th. So square root of 16 is 4. Square root of b to the 4th is b squared. I got an even answer, so no absolute value necessary here. Next one, I have 81, so square root of 81 is 9. A squared, so that's going to be a to the 1st, and d to the 2nd. Now, I ended up with an odd result, so I'm going to put that in absolute value, and that's my answer. Okay, next one. All right, so I have a 40. Now 40, let me just look at square root of 40. That's going to be the square root of 4 times square root of 10, which will be 2 root 10. Okay, so let's put all the stuff on the outside of the square root. So I have a 2, then I have x squared, and then 2 goes into 6, y to the 3rd. And then I'm going to have a leftover square root of 10. Now since this was even, the 6 was even, and I got an odd result, I'm going to just put the y to the 3rd in absolute value, and there's my answer. All right, next one, I'm going to look at square root of 75 separate, so that's square root of 25 times 3, so that's going to end up being 5 root 3. So I'm going to put all the parts that are outside the square root. And if you want to do this separate, that's fine. That's fine. I don't know how I'm doing it all at once is confusing. That's something you can come see me at bonus for. So I take the 5. So basically I'm going to have some stuff that's outside the square root, some stuff that's inside. So I see that I have a 5 outside, a 3 inside. M to the 5th. So take 2 goes into m to the 5th. I get 2 times with a 1 left over. And then 2 goes into p squared 1 time. And since it started out as even, but we got an odd result, we put it in absolute value. Okay, 2 more of these. So first thing I want to do, I'm going to divide this up into numerator and denominator. And the numerator, square root of 12, so I can break that up into 4 times 3. And so the square root of 4 is 2 times the square root of 3. Square root of b squared, so that's going to be b to the first. That's odd, so I'm going to put it in absolute value. And so I'm going to divide it up into square root of 45, square root of 4m squared, square root of 45, so that's 9 times 5. So square root of 9 is 3 with a square root of 5. And then I get 2 and m squared. I got an even answer, so I don't need an absolute value. Okay, the last part of this lesson is on what we call conjugates. All right, we multiply by conjugates to eliminate radicals in the denominator. And basically conjugates are just the middle sign is opposite. So if one is a plus, then the conjugate would be a minus. If one is a minus, the positive would be the conjugate. So I am going to multiply by whatever the conjugate of the denominator. So if I see 4 plus 5, I'm going to do 4 minus root 5. Okay? And just like when we were rationalizing the denominator, we're going to do the same thing here, but we're going to multiply by the numerator and denominator. Okay? All right. So in the numerator here, I'm basically distributing. So I have 2 times 4 is 8 minus 2 times the square root of 5. In the denominator, I'm going to use FOIL. So that's going to be 16 minus 4 root 5, the outside. And the inside is plus 4 root 5. And then the last, I'm going to have a root 5 times a minus root 5. So that would be minus square root of 25, which would just be 5. Now, what do we notice? Well, whenever these are conjugates, and you may remember doing something like this back in chapter 8, those middle terms will always go away. So really, you just need the first and the last. So I have 8 minus 2 root 5, and then 16 minus 5 in the denominator is 11. And we just leave our answer that way. Okay, last one, I see 2 minus root 3, so I'm going to multiply by 2 plus root 3. Multiply by 2 plus root 3. So same thing as the last. I'm going to distribute on the top, so 3 times 2 is 6. 3 times root 3 is just root 3. And now in the denominator, you could do the whole FOIL, but remember what I told you, really just need the first and the last. So 2 times 2 is 4. Minus root 3 times a plus root 3 would be just minus 3. So I get 6 plus 3 root 3. In the denominator, I just get 1. So I'm just going to leave it like that.